Today we're going to take a step back from calculus topics, and we're going to dive a little bit into some more Algebra 2 and pre-calculus based topics, and we're going to talk about quadratics because I know there's a lot of people in the high school that, this is your first really big unit in Algebra 2 or pre-calculus where you really dive into what functions really are. And so today we're going to talk about how to graph quadratics, different methods of solving them, and all that great stuff. So what is a quadratic? Well, in previous, lessons and units, you learned about already a type of function. Let's say I have y is equal to x. You know what this function is. It's just a line. And you can graph it very easily. In this case, it's just going to be a diagonal line perfectly going through the origin. And of course, you learned that really famous formula, y is equal to mx plus b, called the slope-intercept formula. And what you did here was, with different inputs of the slope and the y-intercept, you could make observations and eventually use those observations to graph the function. So if I gave you y is equal to 2x plus 2, what you would do is immediately start, labeling some axis ticks. You would start, the y-intercept is 2, right? So this is eventually going to be part of the line, and maybe, you would start, down to left 1, down to left 1, and then up to right 1. And, you kind of get the idea here, and you would kind of put a line through, and you would graph this line here. And particularly, this is pretty much going to be the bulk of one of the earliest forms of algebra that you learn. Now, what we're going to do is we're going to take this y is equal to x, and now we're going to change it. So what we're going to do is, let's say, instead of having x to the first power, what if we change it to x to the second power? What would this function look like? And that's really what a quadratic is. And in fact, this is a type of a polynomial. And all you have to know is that polynomials are just functions with degrees, in this case 2, that are integers. Or sorry, not integers, positive integers. Not including 0, of course, which is basically a zeroth polynomial, but we don't really care about that. And so this is what a quadratic is. And very simply, what we're going to do now is just analyze things about this, just like how we had the slope-intercept formula and ways to solve linear equations, right? If I gave you this linear equation, it would be quite easy to solve. 2x is equal to 2, x equals 1, and there you have it. But now we're going to do the same stuff and expand upon the quadratic form idea. So let's start graphing this function and see what this really looks like. So let's do some table of values here and maybe get like a couple of points. So if we plug in 0 for x, we're going to get 0 for y. So that's a pretty solid start. So we have this 1 right there. Let's plug in 1. We'll get 1. So 1, 1. Let's plug in 2. We'll get 4. Right? Because 2 squared is 4. And let's even go to 3, which will be 9. So 5, 6, 7, 8, 9. And that will be all the way up here. And in fact, if we, you're going to notice, it's going to be a very smooth curve that looks like this. But wait, what's happening to the left of this? So let's plug in some negative numbers now. So we're going to plug in -1. And that's going to be -1 squared. So -1 times -1 is just +1. Okay, that's interesting. And negative 2 is going to result in positive 4, because negative 2 times 2, negative 2 is positive. And hopefully you realize that the next one will be negative 3 comma 9, and you're going to notice, okay, now I see the pattern here. Even when I plug in negative numbers, I'm still going to get a positive y value. And so this is what a parabola looks like. It's going to be like a U shape. And this is what a quadratic is. And we can talk a lot about it. So, here's something interesting. First, when we have a quadratic, the squared term will always make the input x positive. And what more interestingly is that this is what we call an even function. Because if we plug in 1, we'll get 1. But if we plug in the negation of 1, which is negative 1, we're also going to get 1. If we plug in 2, we'll get 4. Negative 2 will get 4. 3, we'll get 9. Negative 3 will also get 9. And because they're the same y values and they're also symmetrical, this is what we call an even function. Now, if we take that same idea, what if I asked you what the graph of y is equal? Now, I'll actually do this in this color. Y is equal to negative x squared. And remember, this is not saying that this is not negative x squared, because that would just be x squared, right? This specifically means it's the negative of this entire thing first. Okay, so PEMDAS, right? Now, if we do the same graph, here's what we're going to notice. Think about what this is doing. If I plug in, let's do a quick, chart. If I plug in 1, I'm actually going to get negative 1. So my first point is here. And of course, 0 and 0 still remains. But if I plug in 2, I'll get negative 4. And do you see what's going to happen here? If I plug in a negative 1, now I'm going to get a positive 1 after squaring it, but I have to multiply it by negative because of this guy right here. And that's actually going to result in positive 1. Or sorry, negative 1 will result in negative 1. And negative 2 will obviously result in negative 4. And so the property that it's an even function still remains. But this time the parabola is facing downwards because of this negative sign. So if you remember, y equals x looks like a diagonal line, but y is equal to negative x is actually the opposite. Now, instead of thinking as, this part just went like this, they flipped horizontally across the y-axis, what's actually happening is this part went down here and this part went up here. That's the way I want you to think about it. And so in that way, the parabola, which we had right here, and that's what we call quadratics, parabolas, actually turned out, when we put a negative sign, we're actually making it flip vertically. Now, can we have y is equal to the negative of x squared? Yes, but this is really just x squared, right? Times negative 1 squared, so x squared. And think about what this really means is if we have a parabola, and you're going to talk more about this, we're going to talk more about this in a different video when we talk about different functions, but this negative x is, when we put a negative, we're actually flipping the function horizontally. But the parabola is an even function. If we flipped it, it's symmetrical, so it doesn't really change at all. Now, this is very different because, and you're going to learn later, if I have a function y is equal to x cubed, my original graph will look like this, and you'll see that next time. But if I have y is equal to negative x cubed, this entire function, negative x cubed should be written like this. I actually have a completely different graph like this. And think of how it's flipped symmetrically, horizontally. So, just something to note there, but this function is not important as of right now. So, now I'm going to talk about, you understand how to graph these, so let's talk about some more things we could do. The first thing is, okay, you might ask, yeah, we can have y is equal to x squared, but what if we add something? Let's say we add a 1. Okay, so if we do the same stuff with our table of values, let's do the same thing, right? Plug in 0. Okay, so as soon as we plug in 0, we're going to get 1. So 0, 1 is our first point. As soon as we get 1, we're going to get 2, right? 1 squared plus 1 is 2. And now you can kind of think of it as, okay, whatever this one y value results in, it's the same for negative 1. So we can now kind of take a shortcut in some sense. Oops, yeah, there we go. And, okay, well, let's plug in 2. Well, 2 is just going to result in 5. 2 squared plus 1 is 5. And, so negative 1 will be 2. Negative 2 will also be 5 because of the properties of the quadratic. So now you can start graphing these a little bit faster, right? Just taking one positive input and doing the same for the negative input. And, oops, that's not what I meant to do. So we have this right here, and you'll notice that it's still a parabola, but what's different from the original x squared is that we start, instead of at 0, 0, we start at 0, 1. And in fact, this is what the 1 is doing. This is a y-intercept. Remember in y equals mx plus b, this b was your y-intercept. Well, in a quadratic, y is equal to what we're going to see later as ax squared plus bx plus c. This is our c term, our constant term, right? Because there's no x tagged on. Anything that doesn't have an x, that's just a number, could be pi, could be 200,000, whatever, is a constant and is always the y-intercept in this formula. So what it's doing is it's telling us, okay, this one is telling us where the vertex is. And by the way, we call this point at the very bottom, right? At the very bottom, the vertex. So keep that in mind. This is really important. A really important property of quadratics. So understand that this is what we call a vertex. Now, let's keep going. So we already talked about a lot about graphs, but we haven't mentioned some other things. So what if I have y is equal to 2x squared, and let's even add a plus 1. So what is this going to do? So once again, just because we're starting out, we're going to use a chart. So we're going to start with 0. 0 is super easy, right? And of course, our vertex is still just 1. Even if we have this 2 in the front, our vertex is going to be at 0, 1. So that's awesome. Now, if we plug in 1, we're going to get 2 plus 1, right, which is 3. So 1, 3, and if we plug in, we'll just do one more, 2. We'll get 2 squared, which is 4, times 2, which is 8, plus 1, which is 9. So 2 squared plus 1, 2 squared times 2 plus 1. And that's going to be all the way up here. And we're just going to say that's 9. And there you go. And I'll move this away for a little bit. I'll move this down here. And of course, you're going to notice that this parabola is a little bit more skinny in some sense. And if that's what your observation was, then you are correct. Now, it is horribly drawn, but this is what's happening here. So this parabola was very wide, and that's a good observation, and because this parabola is less wide. And that's actually what this 2 term here is doing. And we call this a shrink, or you can even call it, actually, sorry, I think this is called a stretch, but a horizontal stretch. Not because it's getting wider, but it's kind of stretching up and up and up. And so think about what this means. If we have a 2, that means that every input we have for x is just going to be bigger. So if you plug in 1, we're not going to get 1, we're actually going to get 3. If you plug in 2, it's going to be 9. I mean, think about what the difference between that and this, right? The chart for y equals x squared was, values were much smaller. And so that's what that 2 is doing. Now, I mentioned earlier that our formula had a bx term. And we can have, so we have an x squared, let's say we have 3, and now we're gonna, we have a plus 1, same stuff, but we can also add a linear term now. So we can add a, let's say, just a 2x. Unfortunately, there's no real shape that can be determined from this, because as soon as we, start adding things like a negative 2x, we're not too clear on how that directly affects the shape. There are very many reasons, but for the simplicity of Algebra 2, if you were given such a quadratic to graph, you would just have to plug in points. And that's, it's annoying. And so I'll do it for you guys very quickly. We'll plug in maybe like 3 points. 3 is always a good number. So if we plug in 0, we of course have 1. And if we plug in 1, we're going to result in 3 plus 1, which is 4, minus 2, which is 2. And if we plug in 2, we'll get 4 times 3 is 12, plus 1 is 13, minus 4 is 9. I'll say 9 is up there. I'll say 1, 2. Okay. And of course, oops, not what I meant to do. So there you have it. Nice little quadratic with a linear term. Still the same shape, just not really doing too much there. Now, my teacher actually had a fairly interesting explanation for how to approach such a graph. So I'll show you guys really quick. You don't have to know this, but I just think it's very fascinating. So if you have y is equal to x squared minus x, the best way to visualize how this graph is going to do is, so we're going to graph the y equals x squared term in this color, and we'll do y equals x term, negative x specifically. So we're going to split these 2 different types of functions. So now we have a quadratic, and now we have that linear function that I introduced at the very beginning. Now, if we graph x squared, you now know it looks like a U-shaped parabola, and this part should be better. And if you graph negative x, well, you can kind of imagine it's going to look like that. So what my teacher said was, this line is going to pull it, so this part's going to be pulled down, and this part's going to be pulled to the left, this part's going to be pulled up, and whatnot. So that so the final graph will look a little bit like something like maybe this. I don't know, whatever, right? But that's just something fascinating that I thought I could mention, but it's not very important, guys. Don't don't take this method. It's just kind of a funny little method that he taught me. Okay, so now you guys understand pretty much how to graph quadratics. And so we're going to move on to some of the more equation solving. And so just to write it down for you guys, every unit there's going to be in Algebra 2, you're going to learn a different type of function. And you're going to do two things. You're going to learn how to graph them, and you're going to learn how to solve analytical things with them. And so we did this one. Now we need to do this one. Okay. So we have three pretty good methods of solving quadratics. The first method is called factoring. The second method is called completing the square. And the third method is with the quadratic formula. And along this, while we solve this, we're also going to talk about, we're still going to talk about graphing, because there's something that I haven't touched on called the Intercept form and stuff like that, and how to graph those functions. Okay. So let's get into some factoring problems. Say I gave you a quadratic x squared plus 8x plus 16. How would you factor this? And by factor, I really am saying to simplify this or rewrite this as a product of two linear terms. So it should be that ax squared plus bx squared plus c, bx plus c, what I was talking about earlier, this formula, it should turn into a product of two linear terms with x minus p and x minus q, and later we're going to discuss how these are x-intercepts and we can use them to graph functions. Now, how do we find the x minus p and x minus q terms? We can start by doing something called product sum. And in fact, this is going to be the main method I'm going to teach in this video, but if you have your own factoring technique, please go for it. So what we're going to do is put two numbers, and so we're going to put the product of a and c. So we're going to take a and c, and we're going to take the product and put it in here. And we're also going to take the sum, which is just going to be the b, and put it in here. So in our case, our product is just 1 times 16, so it's going to be 16. And our b is just 8, so our sum is 8. So product of 16 and the sum of 8. And all you have to ask yourself here is really, this part's the part where you have to think, is what two numbers have a product of 16 and a sum of 8? And you can start doing this by, and obviously you can do this in your head, but you can start by, listing out what products work. So 1 times 16, 2 times 8, 4 times 4. And this has a sum of 17, this has a sum of 16, this has a sum of 8, so this is our correct numbers. And from here, all you do is now you rewrite this quadratic. And you say this is x squared, and then plus, in whatever order, you can, let's say you go with the product side first, plus 4x plus 4x plus 16. Okay, what do we do here? We just split this as a sum of two linear terms. In this case, they're the same. Now, if it was like 3 and 4, it would just be 3x plus 4x. Well, we did this for a specific reason because now we can factor by grouping. So we're going to group these two right here and these two right there. And now we're going to factor each of them individually. What can you factor out of this side? Well, you can factor out an x, and that'll just leave x plus 4. On this side, it's going to be obviously plus 4 times x plus 4. And you know you did this process correctly if these two are exactly the same. Because what we're going to do is now we're going to factor this x plus 4 out of this sum, and it's really going to be x plus 4 times x plus 4. Isn't that interesting? So these two parentheses have to be the same. And this is actually just, in our case, we can write it in a very special way, x plus 4 squared, and there's your factored form. Let's do another example. Let's say I gave you x squared. Well, let's do this. Let's do 9x squared minus 6x plus 1. So product sum. So our product here is just 9 times 1. So it's just 9. And our sum is negative 6. Include this sign, please. Don't remember. Don't forget. Sorry, don't remember. Don't forget. So it's going to be negative 6. So what two numbers have a product of 9 and a sum of 6? Well, you can now begin thinking of, okay, 1 times 9, 3 times 3, but wait. Up here, we got lucky because I made a mistake. I only did the positive products. And in fact, this is what makes things even trickier, is that now you have to ask yourself, what negative numbers do I multiply? So negative 3 times negative 3 is also 9, and negative 1 times negative 9 is also 9. Now this has a sum of 10, this has a sum of 6, this has a sum of negative 6, and this has a sum of negative 10, and this is what we're looking for. So our pair is negative 3 and negative 3. So therefore, this is really just equal to 9x squared minus 3x minus 3x plus 1. And now we factor by grouping. And we're going to include the negative sign there. And this, from here, we can factor out a 3x. And this will just be x minus 1. And from here, we can factor out just a minus 1. So negative 1 times 3x 3x x minus 1. Oh, sorry, this is a 3 right there. I was just going to say 3x minus 1. Okay, there we go. So that's a good indicator right there that these two have to be the same. And so we factor out a 3x because that's the most we can factor out to get 3x minus 1 here. We factored out a negative 1 from this part. So you can factor out constants in this case because you can't factor out an x. So you have to factor out a constant and so we have minus 1 times 3 times x minus 1. So of course we can now just factor these guys out, and 3x minus 1 comes out, and it's really just like the other case, it's just a square of the two same terms. Awesome. Now these are perfectly nicely written factors, but some factors are not so nice. So take, for example, we have x squared plus x minus 6. Let's try this one. So unlike this one, we're not going to get a square of two things. Just keep that in mind. So product sum, as usual. Why is that p so long? So we're going to have a negative 6 here, right? Negative 6 and negative 1, or negative 6 and 1. And our sum is just going to be 1, which is the coefficient of this. So, once again, we can start maybe brainstorming some ideas. We have 1 times negative 6 as a possible product, negative 2 times 3, 2 times negative 3, and we also have negative 1 times 6. This gives us a sum of negative 5, this gives us 5, this gives us 1, this gives us negative 1. We're looking for 1, so this is our correct pair, so negative 2 and 3. So now we're going to split this, so x squared minus 2x plus 3x minus 6. Notice how we did that there. We took a minus 2x and a plus 3x term. Okay, so we're splitting this into two sums. Now we're going to do factor by grouping, and you can notice that this left-hand side here and this right-hand side here. So we're going to factor out a x from the left one, which is going to just be x minus 2 plus 3 times x minus 2, right? We can factor out a 3 at most. So factor out the most you can from each pair, and you'll get that's the correct method of doing this. And of course, now you know you did things right when these two are the same. So all you're left with is x minus 2 times x plus 3, right? These are, you're going to group the x minus 2's against the x and the 3 added together. And so this is just, this is your final result. Now, why did I just tell you how to factor? Well, what you're going to be asked with is to find solutions to certain equations. And, this is really important because what you're actually asking is, if I have a parabola, some function, and these 2 points are actually solutions to the parabola, the x-intercept. So when we factor, and let's say I took this same exact problem, I said, okay, x squared plus x plus 6 is equal to 0. Solve for x. You can't just go about this normally, because here's the problem. If I said x squared plus x equals negative 6, that might be your first instinct, and you say, oh, x times x plus 1 is equal to negative 6, well, what am I going to do here? What do I do here? Do I just set these individually equal to? So x equals negative 6 and x is equal to negative 7? And it doesn't really make any sense, right? There's nothing really, and you can plug those numbers in back to the original and it's not going to work. So you can't really do anything from here. You can try, it might be like negative 6 over x plus 1. Does this help me? So factoring allows us to solve these solutions. So if we took that same factored form, right, we already did the factoring for this. Now we can, why did I say solve for 6? Solve for x. Now what we can do is, okay, notice, this is a product of 2 numbers. A times b is equal to 0. Now, either a has to equal to 0 or b has to equal to 0. But in our case, we have a variable in here. So we have to set x minus 2 equal to 0 and x plus 3 equal to 0. Because in both of these situations, this equation is true. So when you have a quadratic, you're going to have 2 solutions. Now, keep in mind, these solutions aren't always going to be rational numbers or even real numbers. You can have imaginary solutions. And we're not going to go over too much of that in this video. This is just a basic introduction to quadratics. But keep that in mind. So if we do this, we have x equals 2 and we have x equals negative 3. So we have 2 answers here. And you can check that this works. If you plug in 2 there, we have 2 squared plus 2. This should be a minus 6. Keep making small errors. 2 squared plus 2 minus 6 is equal to 0, and this is actually true. This is good. And you also have negative 3 squared minus 3 minus 6. Is that also equal to 0? Yes. So this is true. So we see that quadratics have 2 solutions, and one thing you can recognize is the fact that what really is going on here is if you have a degree of 2, that means there's always 2 solutions. They don't have to be real, once again, but there are always 2 solutions, and that really goes back to the fundamental theorem of algebra, which I won't talk about in this video, but that's just something to keep in mind. So quadratics have 2 solutions. Okay, so now if I asked you, let's say I have x squared plus 2n plus 4 is equal to 0. And this question can actually be rewritten as this. Now it might say, sorry, 2n x. Sorry, I'm reading off of a practice sheet that I developed. So, and in this practice sheet, I actually wrote this as n. But in this case, how would you approach this? I mean, the first thing you have to do anytime is you have to make sure that one side of the equation is always 0. Okay, that's so important. It must be equal to 0. So first we have to add both sides by 4. So we're going to add 4 plus 4. So we'll get plus 4 is equal to 0. And from here, we're going to do our standard factoring using our product sum method. So product of is going to be 4 in this case. Our sum is 2. And, what two numbers make this equality true? So we have product of 4. 1 times 4, negative 1 times negative 4, 2 times 2, negative 2 times negative 2. Now, unfortunately, in this case, we're pretty screwed. Also, actually, I'm pretty sure x plus... Yeah, so in this case, unfortunately, we cannot factor this. This is non-factorable unless I am missing something. So yeah, I mean, this is a pretty bad problem. I'll erase this part from the video. Okay, so let's say I gave you a problem like, let's just do something a little bit simpler. This is going to be pretty straightforward. If I asked you 25x squared plus 1 is equal to negative 10x, how are you going to solve for x? Find all solutions, right? Or whatever, find the solution of this equation. Solutions. Well, the first thing we have to do is we have to make sure that one side of the equality equation, is always equal to 0. So we need to move this 10x to the left-hand side. So 25x squared plus 10x plus 1 is equal to 0. Now we're going to factor. You can't factor from this situation. So we're going to factor from here. And this is a nicely done product sum. So product of 25, sum of 10. And of course, we can try out, so 5 times 5, 1 times 25, and this already gets us a sum of 10, so I'm not even going to try the negative numbers. So 5 and 5, so this is really equal to, oops, didn't mean to do that, 25x squared plus 5x plus 5x plus 1 equals 0. So we're going to group them, of course. So 5x comes out of here times 5x plus 1 plus 1. So we can't factor anything out of the 5x plus 1. So we'll just leave it as 5x plus 1. And that's okay. And of course, we're going to notice that this is just 5x plus 1 squared is equal to 0. Now, in this very specific case where you have it's a singular term, linear term that's being squared, we're allowed just in this very specific case to take the square root of both sides, sort of. But just make sure that this is really saying that 5x plus 1 is equal to 0. Because this is not entirely true, sort of. Now that system doesn't always work. There's a mathematical error behind saying that you can just take the square root of both sides. But the best way to really say is just, we have this, and you're going to set each of these terms equal to 0, but they're the same term, so you only need to check one. So 5x plus 1 equals 0, 5x is equal to negative 1, x is equal to negative 1 over 5, and in this case we have only one solution. So like I said earlier that there's always going to be two solutions, and in this case there's only one. Now it's only one when you have the case where it's something like this, a single linear term squared. And what this solution is actually, like, let's say it was, if you have a vertex, actually where the vertex is the only time it touches the x-axis, that's when you have a double solution. So that's all you have to know. It's nothing, there is an imaginary solution here, but sort of, not really. It's kind of like the imaginary solution is also this solution. It's like we call it a double root. So yeah. Now, there's going to be cases where you can't always, find a real solution. So with the next solution, I'm going to method of solving quadratics is called the quadratic formula. And we're going to do completing the square last because I find that one the most interesting, but kind of a little bit tricky. So here's the formula. X, the solutions, both solutions to the quadratic of y is equal to ax squared plus bx plus c. And by the way, this is often written as f of x, so start getting used to this. F of x is really y, but just really start getting used to using f of x. And the solution to this is stated to be x is equal to plus or minus, so that's why it's 2, the square root of b squared, so it's negative b plus or minus square root b squared minus 4ac all over 2a. And there's a good song, it's something like x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And yes, I'm a terrible singer, but that's just a quick way to memorize it. So don't spam me in my DMs that I'm a terrible singer, please. But this is your formula, and here's a quick derivation on it. So if we have, or actually, sorry, I can't do the derivation yet. I'll show that once we get to completing the square, and you'll see why. So let's solve some quadratics using this formula. And in fact, let's actually start with the one we talked about earlier, one we already did. Remember this one? Factor it out to x minus 2, x plus 3. And just a quick note, factoring is the undoing, is the reverse of foiling or distributing. Because remember, if you were to do this on the right, you would do like this times this. So x squared plus 3x plus this times that, minus 2x plus or minus 6. And that is where we're actually getting our product sum. Look at these numbers. If you did product sum of negative 6 and 1, it's 3 and negative 2. This is where it's coming from, guys. So we're really doing the reverse. And I wish I mentioned that earlier, but now you know. So we're going to do the same problem. I don't know why I erased that. And we're going to do it solving. Remember, the solutions were x is equal to 2 and x is equal to 3. Okay, so these are our two solutions. And we'll see how we get that here. So our a is going to be 1. Our b is going to be 1. Our c is negative 6. So identify these terms, and now we're going to plug it in. So x is equal to negative 1 plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is 2 times 1. And we should be getting these two answers. And this is a negative 3, by the way. Sorry. Keep messing up lots of things to talk about, you know? And this is really equal to negative 1 plus or minus square root of 1. We have a negative here, we have a negative here, so it's really plus 24 all over 2. This is equal to negative 1 plus or minus the square root of 25 over 2, which is then equal to negative 1 plus or minus 5. 5 over 2. And from here, this is basically saying there are two solutions. If we go the plus route, this is -1 plus 5 over 2. This one is -1 minus 5 over 2. This turns out to just, this left-hand side is 4 over 2, so it's 2. This side right here is -6 over 2, which is equal to 3. And we see our two solutions, the -3, are the same as the solutions here. So they're the exact same. Hopefully you guys see that. So right here. Awesome. So that's quickly on the quadratic formula, and that's the only problem that I'm going to do with. Actually, I'll do one more problem, just in the case of imaginary solutions or some weird solutions. So remember we talked about x squared plus 2x plus 4, and we couldn't, or actually I don't think I mentioned this, but I was trying to factor this while doing the video, and I couldn't because I realized it was not factorable. And you can try this. Do product sum, and you're going to realize, oh, product of 4 sum of 2, that shouldn't be too bad, right? Well, here's the problem, guys. It's 2 times 2 is 4, 1 times 4 is 4, -2 times -2 is 4, -1 times -4 is 4. This has a sum of 4, this has a sum of 5, this has a sum of -4, this has a sum of -5, none of which are 2. So we have to use the quadratic formula. So here's when you use the quadratic formula. You only use it in the case where you can use it anytime actually. The quadratic formula, by the way, guys, it's universal. You can use it to solve any quadratic. It works every time, but it's long. But in this case, we can't factor, so we should use the quadratic formula. So let's do it. Our A is equal to 1, our B is 2, our C is 4, and let me just recall the formula for you. It's x equals -b plus or minus square root b squared minus 4ac all over 2a. So that's your formula on the right. Okay, so x is equal to -2 plus or minus square root 2 squared minus 4 times 1 times 4 all over, sorry, let me rewrite that, 4, all over 2 times 1. And from here, we can just simplify, so x is -2 plus or minus square root 4 minus 16 over 2, and which is equal to -2 plus or minus root -12 over 2. And here's, we can simplify this by dividing by 2. So this is really, so this is really -1 plus or minus root -12 over 2. Now, here's where, okay, you cannot take the square root of a negative number. Think about it. Negative times negative is positive. Negative times, and then positive times positive is also positive. So no matter what you do, you can never have a negative number as a result of multiplying two things that are the same, right? So what do we do here? And this is why we couldn't factor, because this doesn't have any real solutions. So, if you didn't know what to do from here, you would say there's no real solutions. And when we say no real, we mean that there are solutions that are just not real numbers, and this is where your complex number stuff comes in. If you know what this is, you don't need to worry about it right now, but essentially, you can rewrite this as square root of -1 times the square root of 12 all over 2. Okay? And this is a rule of exponents that you can apply. And this is really just -1 plus or minus. And this root 12, you can keep it. That's perfectly fine. 12, I think that's 2 times 3, I believe. So you can actually take a 2 out, so it's 2 root 3. So this is really just 2 root 3, so you can cancel one of these 2's out. So it's going to be -1 plus or minus root -1 times root 3. But this is really just, this root -1 is actually called I. We call it I. It's the imaginary unit. So our answer is actually -1 plus or minus root 3 I. So I root 3. And this would be your imaginary solution. So there you have it. So this is your other case that you might get for quadratics. So yeah. And now we're going to go into probably a more difficult, or not difficult, but just, you know, it does take some work to understand what's going on here. But yeah, so we're going to do something called completing the square as our final topic. So we have complete the square. So this is our third and final method of solving quadratics. So here we go. So big review, I know, guys, but you have to get through this stuff, otherwise calculus is going to be a pain in the butt. But let's say I asked you, okay, x squared plus 4 plus 4, and I want you to, set this equal to 0 and solve for x. Sorry, plus 4x. Oh my god, what is going on with me, guys? I really apologize. It's very late, though. I am making this video quite late in the day, but there we go. Okay, so this is our quadratic. Now, this is doable by using factoring. You'll get x plus 2 squared. But let's say you couldn't do this. Well, we're going to do something different. The first thing we're going to do is we're going to rewrite this, and we're going to get some extra space. So plus something or whatever. And we're going to actually, we're going to, we're going to keep the plus 4 on the right. Plus 4, but we're also going to create some room here. Okay, so create some blank space in between the linear and the constant terms. So here's how it works. You're going to take this term, and you're going to divide it by 2, this constant, not the x. Divide the 4 by 2, and you'll get 2. Then you're going to square it. So square it, and you're going to get 4 here. And if it's positive, do a plus. If it's negative, well, actually, it's never going to be negative. So, it's a pointless question, but yeah. Now, we just came up with a 4 out of absolutely nowhere. So if you add some, to keep the equation the same, and you add a 4, what do you have to do? You have to subtract the 4. So we just added a 4 out of nowhere, so we need to also subtract the 4, otherwise we're breaking the rules of math. But guess what this is? Now we can group this into its own thing. And this is really just x plus 2 squared. And in fact, it's always going to be this. Whatever number you take and you divide by 2, that's going to be the second constant term you're going to add to the x. So it's going to be x plus whatever this number is here squared. And then obviously we have our plus 4, which is actually subtracted by 4. So this is really our final equation. And from here, oh my god, x plus 2 is equal to 0, x equals -2 is our double root solution. So pretty crazy, right? I mean, we completed the square there. And this is actually really, really handy for a lot of problems. So now let's solve a problem here. Sorry, I took a little pause there, but I was looking at my problem to see if it was right. So let's say I have 4x squared minus 12x minus 4 is equal to 12. I want you to solve this using completing the square. And by all means, try it. But here's what I didn't mention for this problem. See, this technique was awesome, but there's a condition. You have to make sure that this constant before the x squared term, or the leading coefficient as it is called, we have to make sure that that's actually 1. So what we need to do first is we need to divide everything here by 4. Or more importantly, multiply everything by 1/4. Okay, and that's fine. We can do that. So we're going to have x squared minus 3x minus 1 is equal to 3. Okay, now, up here, we kept everything on the left side. But I'm going to show you another way where you don't have to actually keep everything on the left side. In fact, you can move just the constant term. Only the constant term is allowed to be moved to the right. So we're going to move this 1 to the right, and it's going to be 4. Okay? And we can actually keep it there. We just have to do something else. We just have to do something when we complete the square. So let's do the same thing, guys. We're going to, create some room. But this time, we're not gonna create more room after there. We're gonna create room after the 4 on the right-hand side. Okay, so we're gonna do that. Now, take half of this with the negative, which is now a -3/2, so that's half. And we're gonna square that, which is going to be 9/4. And we're gonna add it. Now, we just added a 9/4 out of literally nowhere, so we need to subtract it. And we're gonna do it on the other side of the equation. So now we can just tag on a x here and just say that's the left-hand side, right? This entire thing is always going to be a double root square. And we're going to set this equal to basically 4 minus 9/4, however you wish that to be. Now, we can kind of simplify this in a way which is the same thing as 7/4. So, yeah, that's right. Okay, awesome. Now, x minus 3/2 squared is equal to 7/4 is our new little, I guess, equation. Oh, sorry, guys, I just made a small error. I realized that I was thinking of why this was not looking right. Turns out when I did this, okay, it's 3/2, awesome, but you actually have to add it to the other side, not subtract it. Sorry, guys, I didn't mean to do that. If you add something to one side, that doesn't mean you subtract it from the other. You have to actually add it to the other side. So that's what I was confused about. But okay, so this left-hand side stays the same, but now it's just 4 plus 9/4, and that's actually 25/4. And what we're going to do here is we're going to take the square root of both sides. So x minus 3/2 is equal to the square root of this. And that's just 5/2. And so our x is going to equal. And now, here's where I hope you guys caught my mistake, which was when you take the square root of both sides, you actually need to make this plus or minus 5/2. And there's a very good reason for that, because you can have negative values here that are squared that become positive anyways. And now if we solve this, we're going to have x is equal to plus or minus 5/2 plus 3/2. And our two solutions, when you do the arithmetic, will be x equals -1, 4. So these are our two solutions by completing the square. Okay, so sorry about the very complex run through here, but this is pretty much all you need to know about completing the square. So very easy. All you have to do is take half from the middle term, add it, and then of course add it to the other side or subtract it. If you kept it on the left, like in this case, we have to add it and then we have to subtract it. But if you moved it, we have to add it to both sides. Okay, so just keep that in mind. So yeah, there's your 3 methods of solving quadratics, and I'm just going to leave you guys with a couple more things here. So two things. First, let's say I gave you a function x minus 3. So y is equal to, okay, so y is equal to x minus 1 times x plus 3. How would you graph this? It's very simple. All you have to do is first of all, you can FOIL this out, but the best way to do it is just you can use the x-intercept. So the solutions to this equation are actually given to you. They're 1. Is this equal to 0 is what you should be asking. 1 and -3. Okay, so -3. So these are your two x-intercepts, and the parabola will go through this. Now, the reason why after you find that is you have to FOIL it out is, okay, let's say I FOIL this out, you're going to get x squared plus 2x minus 3. The vertex, there's a very special formula. The vertex x-coordinate is -b over 2a. Okay? And there, so if you just plug it in, it's going to be -2 over 2, which is -1. So your vertex x-coordinate is at x equals -1. And once you find this, you have to plug this back into this equation to get the y value of the vertex. So what you just found here was the x value, but now you need the y value. So plugging in -1, you're going to get -1 squared minus 2, basically minus 3. And this is 1 minus 2, which is -3 minus 3, so it's -6. So your vertex is going to be at -1, -6, which is right here. And from here, you can just pretty much guess what the parabola is going to look like, and your teacher should be happy with your answer. The second thing I want you guys to realize is, okay, there's 3 types of situations, right? So this, this, and this. Oops, draw it a little bit better. Okay, so 3 parabolas. Now in this one, this has no real solutions, okay? And the reason is because it never touches the x-axis. The solutions to our quadratics, all the stuff we've been doing up here with the formulas, are all just saying that, okay, this is where the x-intercepts are. This function has no x-intercepts. This one has 2. So you say 2 real solutions, and that's how you denote real. And this has 1 double real solution. And it's actually rational as well. That's just an interesting fact. Now, how do you know if a parabola will have 1 real or 1 double real solution, 2 real solutions, or no solutions? There are only 3 possible cases, guys. And that's when we use the discriminant. So recall that the quadratic formula was x is equal to -b plus or minus square root b squared minus 4ac all over 2a. The b squared minus 4ac part, b squared minus 4ac, is called the discriminant. A discriminant? I don't know how to spell that. Discriminant? I don't know. Maybe that's wrong. But this is your discriminant, and what you're going to do is, okay, if b squared minus 4ac is greater than 0, then there's 2 real solutions. If b squared minus 4ac is equal to 0, there's going to be 1 double real solution. And even it's actually, yeah. And if you have a b squared minus 4ac as less than 0, then you're actually going to have no real solution, but you're also going to have 2 imaginary solutions in this case. And that's that, think of I. And we went over an example of that. So take these cases and you're going to, think about what these mean in the larger context. So I'm going to hold this out for you guys here, and this is great notes for you guys. All right? Now, just a little bit, last little thing, solutions are often referred to as roots. So if you say, if you have a question, find the roots of f of x equals ax squared plus bx minus c plus c, then they're asking for the solutions, which is also asking for the x-intercepts, okay? So just a little terminology stuff there. But all right, guys, that's enough for today. That is a lot of content, I know. And I'm sorry I made this so many mistakes along the way, but I promise this is just a quadratic video for review. And hopefully you guys enjoy. I'll create, there's timestamps for you guys to go to different sections. So, all right, thank you so much for watching. Have a great rest of your day.